Hey everyone, welcome back to Edu-Malanga. We are still working with Unit 1, that is patterns, sequences and series. And in Unit 1 we're looking at Lesson 2, geometric sequences. Today we're doing the second example, example 2 on geometric sequences. And example 2, we're going to get a general term for a geometric sequence and we'll answer questions to do with that general term. If we recall, the general term of a geometric sequence looks like this. You have Tn, which is the term number, is equal to A, the first or the initial term of your geometric sequence, times R, that's your common ratio, and R is raised to the power of n minus 1. If you don't know what's going on here, guys, go back and watch the 2 previous videos on geometric sequences. You'll then be able to stay with us and work with us through the example. The general term for the sequence that we will be looking at in example 2 looks like this. Tn is equal to 6 times 1 over 2, I've got the brackets here now, to the power of n minus 1. So this sequence is what we're going to work with in example 2. The first question we will answer for the sequence, question 1, is what is term number 4 of the sequence that is represented in this general term? And to find a term number, you simply substitute into the general term the number that you have. So we're looking at 4, so it becomes, okay, so let's rewrite it. Tn is equal to 6 times 1 over 2 to the power of n minus 1. N will be equal to 4 for term number 4, so it will become T4 is equal to 6 times 1 over 2 to the power of 4 minus 1. Guys, all I've done is everywhere where you see n, I've substituted 4, and that's why you're seeing 4 here and you're seeing 4 over there. Let me simplify the expression. It will become T4 is equal to 6 times 1 over 2 to the power of 4 minus 1 is equal to 3. I'm going to expand and put the power into the numerator and the denominator. So the expression will become 6 times 1 to the power of 3 and 2 to the power of 3. Let's continue. T4 then becomes 6. 1 to the power of 3 remains 1. So you have 6. And 2 to the power of 3 is 2 times 2, which is 4 times 2, which is 8. 6 over 8. This expression can be simplified because 2 can go into 6 and it can go into 8. So you divide by 2 over 2 and then you get 3 over 4. In this geometric sequence, term number 4 is equal to 3 over 4. The second question that we will answer for example 2, question 2, is does the term 3 over 32 belong in this sequence? To answer this question, we'll again use the general term. So let's rewrite it. Tn is equal to 6 times 1 over 2 to the power of n minus 1. And what we do in this case is we know what the term is, 32 over 2. We don't know n though. We know A, we know R, we just don't know n, and we know what the term is. So we substitute the term onto this side of the equation, and on this side of the equation we solve for n. The expression will then become 3 over 32 is equal to 6 times, in brackets, 1 over 2 to the power of n minus 1. Because we're solving for n, Let's start by dividing by 6 on both sides. I'm going to divide by 6 on this side, and we're going to divide by 6 on that side of the equation. The 6 will simplify the 3 and become 1, and that will become 2. So this expression will then become 2 times 32 is 64. 1 over 64 is equal to 1 over 2 to the power of n minus 1. Let's expand on this side of the expression. The equation will become 1 over 64 is equal to 1 to the power of n minus 1 and 2 to the power of n minus 1. 1 to the power of anything will always be 1, guys. So the expression is 1 over 64 is equal to 1 divided by 2 to the power of n minus 1. Let's look at the expressions. The numerators are exactly the same. The denominators are what we must solve for. If we select only the denominators to work with, we get 64 is equal to 2 to the power of n minus 1. What we need to do to solve this expression is to find out a power of 2 to the power of something that gives you the number 64. Let's start by 2 to the power of 3 because we know that's 8. 2 to the power of 4 is 16. Okay, so 4, 16 to the power of 5 will be 16 times 2, which is 32. And to the power of 6 will be 32 times 2, which is 64. So, 2 to the power of 6 is equal to 64. Let's rewrite it on a new page. 2 to the power of 6 is equal to 64. So, if we come back to the expression that we had over here, we again had 2 to the power of n minus 1 is equal to 64. So that must mean 6 and n minus 1 are the same thing. 6 is equal to n minus 1. If you take the minus 1 to that side, you get 6 plus 1 is equal to n. So n is equal to 7. Because we've managed to find n is equal to 7, the answer to the question then becomes that yes, the term 3 over 32 does belong in this sequence, and it is term number 7. Yes, 3 over 32 is equal to T7. That's the correct answer. This is the end of example 2. Join us in the next video. We will do the last and most complicated example on geometric sequences before we move on to the next lesson.